Okay, so let's look a little bit more at the structure of the group of points of finite order on this curve, y squared equals x cubed minus 4x squared plus 16. In the previous video, we found this addition table for p. 2p is s, 3p is r, 4p is q, and 5p is the point at infinity. Let's first of all see how the addition is working on this curve, and then let's think about this in terms of clock arithmetic. On this curve, if I want to find 2p, then I take the tangent line at p and find where that crosses the curve. So that's p star p. And then I reflect across the x-axis to get 2p. So 2p is s. That agrees with what I have before. To find 3p, let me mark that as 2p. To find 3p, I take p plus 2p. That line is tangent to the curve at s, which means that it intersects at s twice. So p star 2p is s, and then when you reflect across the x-axis, you get p plus 2p. So r is the same as 3p. And notice that r is 3p. To find 4p, I take p plus 3p. Well, the line through p and 3p is a horizontal line, and it's tangent to the graph at p. So remember, that means that this counts as a double point. So the 3 points of intersection are p, r, and p again. So p star 3p is going to be p, and then I reflect across the x-axis, and that gives me q. So that's 4p, which agrees with what I had before. 4p is q. And then finally, to get p plus 4p, I draw the vertical line connecting those, which means that my third point of intersection is that point of infinity, which we're calling O. Now, let's put these points on a circle, p, 2p, 3p, 4p, and O. So this is going to have the same pattern of addition as Z5 does. And I'll also make a note that p is the same as p, 2p is the same as s, 3p is r, 4p is q, then of course O is O. Now if I wanted to add just 2 points on the curve, instead of going through all the algebra that I've been doing, for example, if I wanted to find r plus s, that would be the same thing as taking 3p plus 2p. So r plus s is 3p plus 2p. So here's 3p plus 2 more would be 5p, which is equal to O. Notice that matches what we would see in the picture. Since r and s are on the same vertical line, their sum should be O. If I wanted to find 2s, 2s is the same as twice 2p, so that would be 4p, which is the same as q. So 2 times s is q. 3 times s would be 3 times 2p, which is 6p. But with a clock arithmetic with order 5, 6p is the same as p. So 3s is the same as p. If I wanted 4s, that's 4 times 2p, which is 8p. But 8p, working mod 5, is the same as 3p, and 3p is r. 5s is going to be 5 times 2p, which is 10p, but working mod 5, 10p is the same as 0. So notice that s also has order 5. And it's easy to see that actually p, q, r, and s all have order 5. And the point at infinity is the only point that has order 1.